All right, good morning everyone. Welcome to Hawkridge Systems July 3D Spotlight. This one's going to be the beginning of our summer school 2017. And my name's David Brown and I'm broadcasting live beneath a gray Portland sky. Had a couple days of sun just recently. That was nice, but after 8 months of not seeing the sun, I had to wear some really dark sunglasses in order to get accustomed to that, but it was fun. Hawkridge Systems, Education Surfaces. The focus of today's session is basically our on-demand video courses. Now, if you're familiar with Hawkridge Systems, we offer training in classroom and online training and even custom training we can do. But we also have created in the past months here this year and a little bit from last year as well, a whole selection of on-demand video courses. And perhaps you're very busy, you got a lot of work to do and things like that, and it's difficult to attend an online class or an in-person class at one of our training centers. We have provided these great selection of on-demand video courses for you that makes it very easy for you to get the same level of training in a format that you can access at any time at your convenience. Okay. The title of this session today is Heavy Metal. Now, I have a robot assistant and he helps me do a lot of my work, but sometimes he gets things misunderstood. And he started messing around with my guitar when he heard that the title of this is Heavy Metal. Well, that's not actually what we're going to be working on, not quite that detail. What we're going to do today with this agenda is I've selected a couple items from our on-demand training, in particular the weldments course and the sheet metal course. Weldments and sheet metal is something that's very common in a wide variety of industries, and SOLIDWORKS handles both of these very well. I've selected a couple things for this from these two courses. All right, the first one that we're going to go over is just some basics of 3D sketching. Perhaps you've looked at that a little bit, and you're familiar with 2D sketching, of course, if you're working with SOLIDWORKS. But we're just going to go over some basic concepts of that and get you going with that. And then I'm going to also talk about some other things that you can do with 3D sketching that aren't really related to weldments. All right. And then after that, the second portion of this, I'm going to cover something from the sheet metal course that's called the flange method. Now, there's a lot of different ways to create sheet metal. And of course, that's going to always be defined by your design intent and your products and things that you're doing. Okay. What we're going to cover today with this is just a simple part using the flange method, and we'll cover just a few of the commands with respect to that. All right. So for the first one, what I'm going to do is we're going to talk about some basics of 3D sketching. And what I'm going to do is basically what my robot here, Raiden is his name, and he's kind of sketching with his finger in the air in 3D space. And that's what we're going to do. I'm not going to do that in the air, of course. I'm going to do that using SOLIDWORKS. But we're working in a 3D parametric modeling tool. And we're working in a 3D environment. Now, typically, you're probably used to creating sketches on a two-dimensional plane and things like that. With this, when you get into 3D sketching, there's another dimension that you have to take into consideration. And with that, there are some added relationships that you have at your disposal for creating a 3D shape. Now, in the context of a weldments or a weldment product or object that you're going to create or model, the 3D sketch entities represent a framework. In this case, what I'm going to do is just create a simple weldment table. Let's go into SOLIDWORKS and see what that looks like. Got SOLIDWORKS open here. I'm going to go ahead and just begin a part using an inch template. All right. Now, what I have on my command manager already activated is my weldments tab. If you don't have that, you can right-click any command manager tab and have access to the different types of tools, tabs that you can have accessible on your command manager. And I have weldments active already. And if you notice right at the beginning of this, the very first icon for you to choose is 3D sketch. That's because with the weldment structure, quite often you want to use a 3D sketch. Now you don't have to use a 3D sketch to use Weldment Tools. In fact, you can use a combination of two-dimensional sketches and 3D sketches. They don't all have to be in one feature. They can be in multiple features and things like that. The idea is you create a framework and then you insert structural members based on that framework to create your design. All right. Another location for this tool is on the Sketch tab itself. If you look at the Command Manager, the very first one is Sketch, and the drop-down allows you to access that 3D sketch. All right. You can access this at any location. I'm going to go ahead and just click on that right there. All right. Now, what I like to do when I'm working in 3D sketching is I like to kind of maintain an isometric view, basically, and I like to keep my model rotated so that I have my triad in the bottom left-hand corner here in an orientation that keeps me in a 3D view of what I'm working on. A couple things that you're going to watch me do as I go through this. I'm going to show you a little bit of my workflow and how I like to work with SOLIDWORKS and the parts of the interface that makes it easy and efficient for me to use. One of those things is the mouse gestures tool. And even though I'm entered into a 3D sketch, if I right click and drag my mouse just a little bit, I still have access to my sketch tools, just like I would if I was sketching in a two-dimensional sketch. All right. One thing that I want to point out before I get too much farther here is the fact that when I started this 3D sketch, SOLIDWORKS did not ask me to choose a face or a plane like it would have if I started a two-dimensional sketch. Right. Also, I didn't have to choose a face or a plane to begin this 3D sketch, like I would have if I would have done a two-dimensional sketch, all right? But two-dimensional or three-dimensional sketch is still a sketch environment, so my mouse gestures are going to reflect the customization that I've done to those, all right? And I have my lines and circles and the basic things that I like to have assigned to my mouse gestures, all right? I'm going to go ahead and swipe for a line. Now notice as soon as I activate a sketch tool, it changes my origin in the sketch and it highlights it red, but it's also highlighting the Y and the X axis of my Cartesian coordinate system at my origin, right? And notice also my mouse cursor is now changed to a pencil, just like in a two-dimensional sketch, indicating that I'm going to start drawing a line. And I have the letters X and Y underneath that. That's significant because what that means is that I am now, if I begin to click and start sketching a line, I will be sketching a line on a plane that's relative to the X and Y plane or my front plane. All right. Watch what happens when I do this. If I click out here in space, I didn't select on the origin or anything like that. I just clicked off on the side. Notice what happens. That triad, that highlighted red triad, jumped to where that point was, that end point of that line. All right. And notice I have an inference box or reference box that shows me dotted lines. And as I move my mouse around, that is highlighting or indicating the fact that I am actually sketching in 3D space on a plane that's relative to the front plane. That's really what's going on there, all right? I'm going to click again, and as I move along here, I can create more lines. But everything that I do, I'll create one more line, I guess. All right, got 3 lines in there. I'm going to rotate my model just a little bit just to show you that I'm actually on that front plane. But I am not actually attached to the front plane. In other words, these entities are still free to move in 3D space. All right. Now watch what happens when I select some of these lines. If I click on one of these lines, I have a pop-up here that shows me that I have make along X, make along Y, and make along Z. If I look at my property manager on the left-hand side, I have some additional relationships that I don't have when I'm using or sketching in a two-dimensional sketch environment. Okay, this is the added thing that you have. So what I'm going to do with this is I'm going to just make this line, and notice that it highlights the along X relationship, because that's how I sketched this line. It's closest to that. All right, so that's probably the one that I would want. So I'm going to go ahead and do that. I'm going to select this one here, and from this drop-down menu, pop-up menu, I'll make that one along Y. With this one here, I'm going to select this one and make it along Z. Now look what happened with that. That put this line going off the back. All right? Even though when I sketched this, my sketch orientation was relative to the front plane, these lines are still in 3D space. This is the challenge that you have when that you have to deal with when you're sketching in a 3D sketch environment. You have to take that third dimension into consideration. So you have to be very careful with that. One of the things that I like to tell my students in all of my classes is that SOLIDWORKS is a very powerful tool, and it is constantly waiting for me to do my next click. So what I try to do is I try to be as extremely precise and deliberate with every click that I do in SOLIDWORKS, right? And I also take advantage of the feedback that the system is giving me. All right, I'm going to go ahead and turn on my sketch relations using the eyeball up at the top, hit the drop down, and I'm going to choose this little button right here, View Sketch Relations, so that we can see those relationships that have been added onto those. All right, I'm going to go ahead and highlight all those and delete that. All right, let's get back to our actual thing that I'm going to sketch here, right? What I want to do with this, and if you remember the PowerPoint that I just showed you a little bit, there was some sketch geometry on the top plane, basically at the origin. I'm going to use that to create this framework, because what I want to do is I want to create a framework here that I can insert structural members on, and I want to be able to control this thing. It's going to be a table, welded workbench or whatever, with a shelf on it. And I want to be able to control that with just a couple dimensions. Those dimensions will be based on my design intent of what it is that I want to do and control. All right. The other thing I like to do when I'm sketching, in addition to my mouse gestures, is the S key on my keyboard. I like the shortcut menus, and because I am in a sketch environment, I have access, it activates this same shortcut menu. I'm going to choose a center rectangle for this. And once I activate that tool, it highlights that origin and showing me that I'm relative to the front plane or the XY plane. But I don't want that orientation. I want to sketch on the top plane or the ZX plane. While you're in a 3D sketch environment, the other thing that you want to focus on or remember is manipulating the environment so that you're sketching in the correct area that you intend. This is accomplished by pressing the Tab key once you're in a command. Notice what happens as I press the Tab key, it cycles through those standard planes, right? ZX, XY, YZ, ZX. That's what I want, all right? So I use that as I'm sketching and making sure that I'm deliberately doing that. What I'm going to do is I'm going to begin at because I have a center point rectangle, I'll begin at the origin and I'll just sketch a rectangle out from that and click to place that, hit escape to exit that command. I'll rotate this just a little bit and zoom in so now you can see the different relationships that I have on here. Because I chose that center rectangle, it automatically has these lines in it, these construction lines that go through the center of it. And as I sketched that on there, it automatically added along Z and along X relationships, and thereby fully defining that construction geometry in there. So that helps to control that rectangle. All right. Notice the others, because I've done a rectangle here, I've got the midpoint relationships that you'd expect on those construction lines, and the parallel relationships and the perpendicular relationships that you would expect when drawing any kind of rectangle in SOLIDWORKS, right? So that's helping to define that the way that is. All right. Now what I'm going to do is I want this to control the basic width and length of my table, right? So this is all going to be construction geometry. So I'm going to highlight these two and these two other edges and turn those into construction geometry. Next thing I'm going to do is I'm going to swipe for a dimension, and I'll dimension this out 36 inches by 24 inches, right? Hit escape, takes it out of that tool. Now I have a foundation that I can build my table on. This will help me to control the width or depth and length of this table. All right. I'm going to keep my green boxes on for a while. Typically, I don't like to have those on because I know exactly when I'm working in SOLIDWORKS, I know exactly what relationships I'm adding at any given time. Now, just to kind of review sketches and things like that, in order to fully define a sketch, you have to have two things: relationships and dimensions. I list those in that order because relationships I do first. I capture all the relationships based on my design intent, and then when I'm left over, typically with the key dimensions that I might want to change later on. All right, let's build this table. I'm going to swipe for a line, and I'm going to do one end first and then another one. Now I'm at the ZX orientation, so I'm going to tab to the X and Y orientation. And I'm going to click on a corner, an existing corner, and I'm going to project up with my mouse, move up with my mouse, and I'm going to automatically capture, based on my inference lines, the along Y relationship. All right, so I build that in as I go. Now, because I'm in an XY orientation for this 3D sketch environment, I can very easily pick up that along X relationship for this line coming off this way, right? If I was in a different orientation, then I'd be sketching on a different plane, relatively speaking. So I'm just going to come across here just a little bit to capture that relationship, and then come down to this corner to fully define that, and click that line and make a long Y. All right, so now this is fully defined with except for the height of that. I'm going to do that on the other end. Swipe for a line, click capturing that other relationship, moving along that inference line to pick up that relationship, and then I come down, finishing that off, and make that a long Y. Now, I have two ends here, and they work independently of each other, right? If I wanted one side to be higher than the other, then I would put two dimensions on there. But that would be the design intent of that part. The design intent of my table here is going to be such that the two ends are equal. So therefore, I'm going to make them equal, and then control them with a single dimension. That principle right there, if you don't understand that principle, you should grasp that principle, because it saves you a lot of headaches when you want to make changes. All right, design intent drives every decision. So what I'm going to do is I'm going to select one of these lines from one side, hold my control key down on my keyboard, select the other one, release, and make it equal. Notice these other relationships, same ones you get when you're working in a 2D sketch, right? You get those as well. I'll make those equal. Now they work together. I swipe for a dimension tool here and dimension the height of this 32. Hit escape. All right. Now again, I don't like these green boxes, so typically I don't model with them on. I only really do that in my classes when I'm illustrating certain things, or if I need to investigate things, I'll use that too, and I'll turn them on just to see, making sure that I'm doing things right. But I like to model without that stuff in there. All right, I'm going to finish this off now with a line. And now here's something that's interesting. I'm going to add a line on the back and on the front, and I don't have to worry about my orientation with the tab key because I'm going to literally click and define the endpoints with coincident relationships by selecting entities that are already in this 3D sketch environment. So if I select these two endpoints here, it attaches that and fully defines that. I'll do one more and finish this up. All right. Now the next thing I'm going to do is add a rectangle in the bottom of this. Now the one that Raiden did in the image before had a little bit of different cross section there. That doesn't matter. I'm going to choose to do this one a different way. Press the S key on my keyboard, choose corner rectangle, and I'm going to select one corner and the other corner. Now notice this one does need to have that, well, it'll help it actually to have the correct orientation. So I'm going to tab over to the ZX orientation. Notice I did that right in the middle of the command. So you don't have to tab that. You can do that right in the middle of the command. All right, so go ahead and select that guy, and that almost fully defines that. But notice what happens. I can move this up and down, and it works independently, and it'll flip around and do all kinds of weird stuff. So now because you're working in 3D, you have to take that into consideration. So I'm going to click on this end and make that one along X. All right, now this can go like this, but it will still, it's starting to take shape here. Select on this one, make that along Z. Now this will just simply go up and down. Now all I have to do is dimension that and set the height of my table, of my shelf. All right. That's the basics of 3D sketching. I'm going to go ahead and exit out of this. And there's my framework, all ready to accept structural members with the weldment commands. All right, now I've got a lot more to show you today, so I don't want to get too far in this. But basically at this point, I would switch to my Weldments tab, and I would choose structural member and choose my standard. These drop downs represent folders on your hard drive. I show you in the classes and in the videos how to go ahead and set all this stuff up with extra things and all that kind of stuff. And we do custom profiles and all that. I'm just going to set all this up and go ahead and select my edges. Select a new group. Put the legs in there. Select a new group and do the last one at the bottom here. Right click when I'm done. And because I did all of this in one feature, it automatically trims all of those segments. All right, I'd swipe for an isometric view and I would hit save at this point. That's the basics of 3D sketching. I'm going to return to my PowerPoint here. 3D sketch basics, creating a framework for weldment structures. But 3D sketches are not just for weldments. You can do these to drive a variety of product models. If you look at these images here, the one on the left is a structural member, or a section of a light cage or something that you would see in a rock show or something, some musical production or something like that, right? Or something on the space station or whatever and floating around in space supporting something. That's really cool. Look at the one in the middle. This is a Kanban system, and it was actually, I created this one using a 3D sketch, drives that whole thing, and I can configure it with different sizes and things like that. And it's using something called Creeform, which you purchase tubes and these plastic connectors, and you can build that. And I used a 3D sketch to create that and drive that. On the right, and it's not welded together, it's just put together, but a single 3D sketch drives the entire thing with configurations and everything like that. The thing on the right is a bookcase, right? Let's take a look at that a little bit. I'm going to go back to my SolidWorks here. And in my design library, I've got a couple things, links to those project folders where those are located. And I'll just open up this stand here for you just to look at. And if we look at that again, I basically modeled up the plastic connectors. I created a part. With this one, I created a part that has a single 3D sketch in it. Those are the only dimensions in this model. Changing these 4 dimensions changes the overall size of this. Now I have mates in here that position the location of these shelves and stuff like that. So in that respect, I do have some mates, and usually I group key mates in a folder so that I can access those really quickly, and then I can modify those, and I rename them and things like that. This is an organizational thing that I like to do, and I cover that kind of stuff when I'm in my classes and things like that. But if you look at this, I'm able to control this whole thing with just a couple dimensions in a wide variety of configurations. All right, all within the context of an assembly, 100% created from top-down assembly modeling, except for the connectors, of course, and creating that Kanban system, right? I could create those all day long just based on this simple model here. I'll close this one. What I really want to show you is this bookcase. And I've got 2 versions of this bookcase. So I'll open up the multi-body one. I've created this bookcase in 2 different ways using multi-body part design. Notice what I have in this. On the cut list, I have a cut list rather than a solid bodies folder. And that has the different panels in it, all named. And below that, I have the weldment feature at the top of that. Adding that weldment feature into a part, even though I'm not using weldment structural members, I'm able to create and have access to the cut list item. This particular bookcase has these different configurations in it. I've got a 3-shelf, a 5-shelf, and a 4-shelf bookcase, right? All within that. I have the same thing designed in a multi-body part environment. Let's take a look at that a little bit. Go back to my PowerPoint here. The on-demand Weldments course has a 2-hour video bonus content called a 15-minute bookcase. And you will not find such an in-depth discussion of this concept anywhere that I've been able to find. I do the same bookcase in 15 minutes as a multi-body part environment using the weldment feature to create a cut list. And it's all based on a 3D sketch. And then I create all the panels. I create the same bookcase in a top-down assembly modeling, again based on a single 3D sketch to drive the entire model. But it's 100% created using top-down assembly modeling techniques. The difference between these 2 is one of them, with the multi-body part, I get a cut list. The other one, top-down assembly, I get bill of materials. The 15-minute bookcase bonus content is almost 2 hours, 6 different videos. The first 2 videos I show you how to create the bookcase using top-down assembly modeling, the same bookcase using multi-body part design. And then the key thing in this is part number 3. There's a half-an-hour discussion and going into the details of the 2 drawings that you get when using one method or the other. And it goes and it outlines the benefits that you get with using the weldment feature in a multi-body part and the cut list, or as opposed to bill of materials. It all depends on what your output needs to be. That's design intent, all right? The other options the other videos that I have in there are part number 4. I show you how to create the library feature parts that I use to create the holes for the adjustable shelves in the side panels. And then in 5 and 6, I go through how to create the assembly configurations and how to create the configurations in a multi-body part environment. There are some differences. This 15-minute bookcase, 2-hour bonus content is in the Weldments on-demand course. Very, very valuable. All right, excellent stuff. Okay, that's the first half of my discussion here. Let's move into sheet metal design. And what we're going to do is I'm just going to take a portion out of that class and just show you some typical content that you would get from that class. So let's go jump into that. Activating SOLIDWORKS again. What I'm going to do is I'm going to start this part using part millimeter template. Hit OK. Now I don't need my Weldments tab anymore, so I'm going to turn that off. I'll right click, uncheck that. I want my sheet metal tools back, so I'm going to right click on that, activate sheet metal, and we'll go ahead and work on this. The flange method for sheet metal design in SOLIDWORKS takes an approach for creating a sheet metal part based on its finished state. So we're going to create the overall profile of this. I'm going to go ahead and choose the front plane and begin a sketch. Now we've left 2D, 3D sketches. Now we're just into standard SOLIDWORKS stuff now, right? Two-dimensional sketch. I select my front plane, begin a sketch, and I've entered into that. All right, I'm going to use my S key, pick up a corner rectangle. Using my inference line off the origin, I'm going to create that rectangle just like that. Watch how I do this. I select that line and hold my control key down, select my origin. From the pop-up, I add a make midpoint relationship, and while that pop-up is still active, I can just move it right down a little bit and toggle that to construction geometry right there. That is why, it's a very subtle thing, but that's why I really stress that when you're working with SOLIDWORKS, that you are very precise and deliberate with every click that you make. And pay attention to the things that pop up from the user interface, because SOLIDWORKS really has done a brilliant job of creating an interface that interacts with you, and if you pay attention to it, it really anticipates and helps you along with your workflow, making you very efficient. But you got to take advantage of that. All right, now what I'm going to do is swipe for a dimension and pick up that line right there, 420 by 76. All right, hit escape. Now I've fully defined this. I'm going to turn off my sketch relations because I don't like to see those. All right, now I'm fully defined with this. I'm going to rotate this just a little bit. Don't have to. Now what I could do is I could come up to my sheet metal tools tab up here and press base flange tab. But I'm not going to do that. I'm going to show you a little trick that I did. I'm going to press my S key. Now I'm in a sketch environment. But if you notice at the bottom of my shortcut menu that I activate when pressing the S key on my keyboard, I've added and customized this to have an extruded cut, my base flange tab, and extruded boss. Because a lot of times when I'm in a sketch, I like to go directly to those things without accessing anything else. And if I have those customized on my shortcut menu, I just simply press S and then I can activate that. And that's exactly what I'm going to do. Now what I could do is I could take this little arrow here and I could drag this out and put it on 240 or whatever. But let's take a look at the property manager of the sheet metal tool here. Up at the top I have direction 1, just like anything, and I can specify my dimensions in that just like normal, right? As I go down through this, I've got sheet metal gauges. I'll talk about that little box here in a second. Sheet metal parameters, there's the thickness of my sheet metal and the basic bend radius that is going to be added into this. Now if you notice this, it's taking my sharp corners and adding that bend radius to those sharp corners, creating a bended sheet metal part. Down here I've got a drop down that represents different methods for calculating bend allowances. We talk about that in detail in our courses, on-demand videos, as well as our regular classes. Auto relief, ob round. There's a couple different selections on that. I'm just going to keep those standards. What I like to do, though, is I like to use my sheet metal gauge table. So I'm going to select on this, and there I am presented with a drop-down. This drop-down represents a folder on your hard drive that SOLIDWORKS installs basic sample Excel spreadsheets for you. The idea here is that you take those spreadsheets, these sample spreadsheets, open them up, edit them with your data from your manufacturing processes and the materials that you work with. That's the data that you populate these sample tables with, and customize it to reflect what you do at your company, right? That's the idea behind all this. So I give you these samples. I'm just going to select the sample table. We show you how to do all that in the on-demand videos. All right, now I'm going to choose a gauge of 20 gauge, and doesn't matter, 3 millimeters. For the bend radius. All right, now notice what's going on with this. I'm going to go ahead and click my little blue arrow on my reference triad and then zoom in on this corner, and I can see that the material is being added to the outside of my sketch profile. What that indicates to me is that my design intent of these dimensions is governing the inside dimensions of my cover that I'm creating. If I want it to be the other way and they're outside dimensions, then I select reverse direction. I'm not going to do that. These dimensions represent the inside dimensions, which is the most critical. So I'll keep it the way it is, and I'll select OK, swipe for an isometric view, and I'm going to save this on my desktop, and I'm going to call it cover. All right, there we go. Now what I'm going to do is take a look at what's happened to my feature manager tree. At the top, there's a folder. If I want to change the parameters that I just specified, I can click on this folder and edit the feature. And here I could change the gauge to 18 if I want, and maybe 2, right? Just change that. That's where you go to edit that and make that change. The other thing I want to draw your attention to right now is the very bottom, and I'm going to select the tab for my my command manager for sheet metal. And there's a button way over on the right-hand side that says flatten. Now, if you notice the bottom of my feature manager tree, there's a folder that says flat pattern. It's grayed out, or it's suppressed. Here's what happens. If I click on the flatten button, sure enough, that's what I get, a flattened version of my sheet metal part. And then all of these items under here now unsuppressed. Notice there's a sketch in there for the bend lines, and there's a sketch representing the bounding box, which is the minimum material requirements necessary to form this part. In the right-hand corner, confirmation corner, is a button to return to my folded state. All right. Let's add some more stuff into this. I'm just going to go through and show you a couple different commands with this. All right. I'm going to add some edges, edge flange. Basically, I select this up here at the top of my command manager, and I choose an edge. It doesn't matter if it's the outside or inside edge. I click once to select an edge, and then I can move my mouse in one direction or the other. The second mouse click defines the direction of that flange. Once I do that, now I can choose other edges and add those into this on that side. I'm going to zoom into this corner right here, and as we work our way down the property manager, one of the first boxes here is gap distance. So I'm going to leave a gap distance of 1 millimeter right there. And an angle, I'll keep that at 90. I have a flange length that I can specify, and I'll put that at 16 millimeters. All right. And then there's some buttons down here that you're going to control the measurement of that flange length is measured from the outer virtual sharp or inner virtual sharp or the actual tangent bend. There's also a flange position. Notice what happens as I select these: material inside, material outside, bend outside, and it basically just changes the position of that bend as it's coming off that edge. Again, you have to take into consideration the design intent of your part for that. All right. That's all I'm going to do for this right now. I'm going to go ahead and click OK. And that creates that bend. Swipe for an isometric view, hit flatten to double check my part. Looks good. Return to the folded state and hit save. That's pretty much how I do my things. I always return to an isometric view before I do my next command and stuff like that. That's kind of my workflow. Let's add another flange on this right-hand side over here, but this one here is going to be, I'll go ahead and select edge flange first. Click on an edge, move my mouse to define the direction, but I don't want it to go the whole edge. I want to modify this profile. At the top of the property manager for the edge flange tool is edit flange profile, little button right there. What this allows me to do, when I click on that, it opens up this dialog box up at the top with a couple buttons on it. And it really enters me into the sketch of this profile. All right. And as such, when I activate my mouse gestures, I can see I have my regular sketch tools. I've customized mine so that I have bottom swipe, or the south swipe is my normal to view. I'm going to swipe for that, normal to. And what I can do is I can actually push these sketch entities and make a change to that. All right. Push those around like that. Now I can modify this. I'm going to actually pick up a circle. Here's a little trick I like to do. I'm going to turn this so that it has an arch on the front of it. So I add a circle in there, swipe for my trim tool, and then select that line and turn it into construction geometry. Now I retain all of those sketch relations just by doing that without having to do a lot of extra editing. All right. I'm going to go ahead and swipe for dimension, and I'll dimension 30 millimeters from this edge, 15 millimeters, and then a radius of 10 millimeters on that. All right, and that creates that. I'm going to move this down here a little bit, and now I've created that fully defined, modified flange profile. All right, now I'm done with this. So now I'm going to address this profile sketch dialog box up here. I have a couple buttons. There's finish. If I click finish, that will actually finish what I'm doing and end the whole feature, right? And create this flange as it is. I don't want to do that. I want to click the back button, so that will return me to the property manager of this command. That way I can verify that the flange position is correct, and it is, it's material inside. But I also wanted to you to notice that since I fully defined this with relationships and dimensions, I don't have a dialog box or a text box to put a value for the flange length. All right, that's what happens when you do that. I'm going to go ahead and hit the green check and accept that. Now, working with these types of features are basically, it's just a feature, so you have the same linear pattern. So I'll do a linear pattern of this. Select that edge. Specify a value of 120 for that. Features and faces, I'll go ahead and select that, and I'll right-click to add a linear pattern of that. Now, because I modeled this, or I sketched this with relation to the origin being in the middle of this, that very conveniently gives me the right plane that I can use to mirror, because this thing is symmetrical. Very common thing that I do with most of my parts is have the origin in the middle somewhere, because then I very conveniently have planes based on the origin that I can use for mirroring and addressing symmetry and that kind of stuff. All right. So I select my plane, select mirror, rotate this a little bit, and I'll just choose both of these, right click, and there I am. There I am. All right, and I've got those mirrored to that other side. Swipe for an isometric view, hit save, sheet metal, check my flatten. Everything's working out great. All right. Now I'm running short on time here, so I'm going to get moving a little bit. There's a couple other things I want to show you. I'm going to hold my shift key down and press my arrow key, up arrow key twice. What that does is that rotates my model, so I'm now looking at the back underside of this. And I'm going to add a plane on here. What we're going to do is we're going to choose features, reference geometry. I'm going to select a plane, and I'm going to choose a line and a vertex, right click to accept that. Now I have a plane that I can sketch a profile on for the miter flange. That's what we're going to do here. That's driven by a sketch. So selecting the sketch, I'll begin selecting the plane, I'll begin a sketch, swipe for normal 2. I'll zoom in on this corner, pick up a line, starting at the origin. Very carefully I zoom in, come across here a little bit, put a couple lines in here, hit escape, dimension these, 20 on that one. From the end point to the origin, make that one 40, and put an angle on here of 60 degrees. Now it's not fully defined yet, so I'm going to select the first line and the other horizontal line and make those equal, fully defining that right there. All right, rotate this down a little bit. I don't like to see this plane, so I'm going to click on it and hide it. Now I've got a fully defined profile there. I'll go up to sheet metal, select miter flange, can do that right within this part. And because I've got radiused edges on these corners, I can take advantage of this little box that pops up to propagate this profile along those edges. So I select that. That captures all of those edges. Make sure that my flange position's where I want it to be. I'll do material inside, a gap, 1 millimeter, and select OK. And now I have that very complex profile on that, just like that. All right. Let's do another thing. Let's strengthen this with a hem. What I like to do with these, now this is important on which side or edge that you choose, because you'll put the hem on that side of this edge flange, right? I like to specify the type and size first. So I'm going to go ahead and specify the type as being closed and material inside with a dimension of 8. Now I'm going to rotate my model just a little bit using my middle mouse wheel so I can see the back side of this. I'll zoom in and I select those two edges, rotate, zoom in, and right click to add that in there. And now I have a flange or a hem that strengthens that on the inside. All right. Swipe for an isometric view, hit save, double check my flat pattern to make sure that everything is working good. All right. Now you may have noticed that the base flange command in here says base flange / tab. We're going to do the tab portion of this, and I'm going to put a tab on the front of this. I'm going to select this face and begin to sketch. You do that just like any other component or part in SOLIDWORKS. Swipe for a normal 2, swipe for circle, pick up the midpoint of that edge, draw a circle, swipe to pick up my dimension tool, and I'll dimension this at 20 millimeters. Rotate that just a little bit, press the S key on my keyboard, and choose the base flange tool. What this does is it automatically adapts the specified parameters that we defined at the beginning of this model. And then I click OK. So it's very easy to add a flange or a tab onto something like that. All right. Now let's take a look at some cuts. Cuts are the same. I'll just click on this face, begin a sketch, put a circle on there, hover over that, put a circle, right? Just like anything, press my S key, I've got a extruded cut in there. Now here's the added thing that I want you to pay attention to. When you're working with sheet metal and you're doing a cut through it, you have an option for link to thickness. So I'm going to link to thickness, don't have to worry about the direction or anything like that, and I click OK. And what that does is that links that cut to the thickness of the sheet metal. So if I go back and change the thickness of the sheet metal, it'll update that cut. Let's put another one on the back side. Now this one is really important. Because I've got a slanted face here, I'm going to select this back edge flange here from the miter flange, begin a sketch, press S key, pick up a rectangle. Using my inference lines, I'll just sketch a quick rectangle there. Swipe for normal 2, select that bottom line, hold my control key down, and make that midpoint. Put a dimension of 25 by 85. All right, now I've just got that regular old cut there. I'm going to press my S key, activate my cut, uncheck link to thickness, and specify a depth of 10 millimeters. Now, here's what I want you to pay attention to. Normal cut is an option at the bottom of this dialog here. This is very important when you're creating sheet metal designs, because when you get this thing all done, I'm going to go ahead and click this green check and cut that in there. Notice the face of the cut. It's slanted. It's actually normal to this slanted face. This is important because when you flatten it, because this is how you're going to do this, once you get this thing all done, you flatten that out and you have a nice straight face there that your laser cutter or your water jet or plasma jet or whatever it is that you're going to use to cut this will be nice and happy, right? If I didn't do that, if I didn't put a check mark in that box, then this face would be slanted. Very important. All right. I'm going to go ahead and exit out of this, swipe for an isometric view, and hit save. And of course, just like anything, I could add a whole wizard feature on here, select countersink, anti-metric, my size, just like anything, and I can position that, select a face, and I can add these into my design. All right. A lot of different ways you can do this. I could have used my rollback bar and put this before the linear pattern on the first one and then incorporated that feature and all that kind of stuff. All right. There we have it. That is the flange method. Pretty quick little demonstration there. And covering a little bit of the sheet metal parts and things like that. All right. Returning to my PowerPoint now. What we've just talked about is a couple selections from our on-demand videos. All right, that kind of gives you a little bit of indication of what you can expect from our on-demand videos. 3D sketching from the weldments and flange method from the sheet metal one. Right, on-demand videos. Learn at your own pace, on your own time. They're convenient. No need to travel to a classroom. You can learn at home, office, coffee shop, the beach, wherever, 24/7 for 1 year. That's a long time to have access to these videos. You can go over them and over them and over them. They're efficient. We've created these videos, and the interface that we use, the delivery method, is very easy to use. Everything is on one page. It's straight to the point. What I want to do is, I'm busy. I've got a task to do. I've got projects to work on. I want to see the expert do the task. And that's what we do. We get you straight to the point with high quality audio and video production in our on-demand videos. Flexibility, multiple devices are supported. It's through your web browser. And you can access this on tablets and cell phones. You can even project it. They look great on my 50-inch HD smart TV in my living room. All right. These are our current titles, and there's more to come. SolidWorks 3D CAD, sample content with Raiden. That's my robot. He's got a video that he created, 5.5 minutes, that shows you through the steps for creating an account, a student account, and things like that. And it's pretty cool, right? He does a really great job of creating giving you a good taste of what it's like from a student perspective. We have Getting Started with SolidWorks, which is a project-based introduction to SolidWorks, 13 hours, 50 videos almost, and it's based around the engine components of an RC car. Pretty cool. And not only does it cover some basic stuff, but there's some advanced things thrown in there as well. Then, of course, we got weldments and sheet metal, which you saw a little bit of that. Got ANSI drawing, surface modeling, mold design, SolidWorks motion, intro to SolidWorks simulation, SolidWorks routing electrical module. We have other products available, inspection, circuit works. Composer is coming. Visualize is coming. We're working on those titles. More CamWorks titles. We've got 2.5 Access Quick Start, Wire EDM, Nesting Works. All of those are fantastic. This is the on-demand course offering website, all right? education.hawkridgesys.com. If I click on this, opens up my web browser here. I'll give this over here. This is the page, and basically very easy to use. You can see the tiles. The very first one is the sample content, on-demand courses, on-demand videos with Raiden. If you click on that, that'll take you into that, and all you have to do is, it's free. Go ahead and watch this video. And he goes through and it just starts to play, and it gives you kind of a basic introduction of and sample of what it looks like and all that kind of stuff. So there's Raiden. He goes through and he talks to you and stuff like that, but he also shows you the different interface and how that works. All right, pretty cool. Make sure you watch that. I'll go ahead and turn this off here. All right, that's where that is. Now, this summer, here's our special on-demand special summer promotion. Get 25% off SolidWorks and CamWorks on-demand training courses, July through August. Promotion ends August 31st. Make sure you take advantage of this special offer. And that's it. That takes us to an hour. Thank you for attending. There's Raiden. He's back to playing with my guitar again. Hawkridge Systems. On-demand video website, http education.hawkridgesys.com. Check that out. Check out Raiden's video. You can actually reach that same area if you go to our website, which is www.hawkridgesys.com, and you select the training tab up at the top, and there's a drop down. Just choose on-demand videos, and you'll be able to see all kinds of information. And Raiden will tell you about that if you watch his sample video. But all of the tiles there's frequently asked questions. It gives you different requirements, what it's about, who the instructor is. There's tons of information in there for you. Email us at info@hawkridgesys.com or support@hawkridgesys.com. And of course, in the bottom left-hand corner, there are some phone numbers, USA and Canadian. Contact your sales representatives today. Hope you enjoyed this video. Raiden and I really enjoyed putting it together for you.